Dear learners, once again welcome back. We are moving to new model, that is unit 3 of hybrid electric vehicle, that is energy sources. So once again I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. I welcome you all once again for this wonderful session. So today's content: battery parameters, types of batteries, battery modeling, quick charging devices, fuel cell, battery management systems, conclusions. So first we will start with battery parameters. Whenever we talk about battery, that battery is very much important to drive electric vehicle as well as hybrid electric vehicles. The parameter must be studied to know the condition of the battery, to assess the battery or what is the type of battery, whether it suits for our vehicle requirement or not. So one by one we will see the storage capacity. It is mentioned in WH, that is watt hour. So it refers the number of hours for which the battery can be discharged at a constant current to a defined cutoff voltage. So how much power available in the battery to supply how many hours. So this is storage capacity of the battery. Then energy density. So watt hour per meter cube, that is watt hour per volume, per unit volume we can say. The energy density is the amount of energy that can be stored per cubic meter of battery volume, expressed in watt hour per cubic meter. Then specific power, so watt per kilogram. So how many watts can be stored per kilogram weight of a battery? This is specific power. Then state of charge. So how much amount of power stored in the battery or energy in the battery relative to the total energy capacity of the battery. It can be expressed as percentage. So depth of charge, DOD, it is expressed in percentage. This parameter expresses the battery capacity that has been discharged relative to the maximum capacity. So how much percentage of energy can be discharged from the battery to become empty. So this is depth of discharge. Then cycle life. The number of charge or discharge cycles that the battery can experience before it reaches a predetermined energy capacity or other performance criteria. So how many numbers it can withstand for a particular capacity or particular performance. Then self-discharge. This parameter defines the reduction in energy capacity of the battery under no load condition, that is open circuit, as a result of internal short circuits and chemical reactions. The self-discharge will occur when the number of hours without keeping the battery charging or without discharging. The self-discharging will be very minimum, hour by hour it will be reduced due to the short circuits and chemical reactions. Then round trip efficiency. Due to internal losses and material degradation, not all the energy supplied to the battery during the charging can be recovered during discharge, because amount of energy that can be taken from the battery during the discharge process over the energy supply determines the round trip efficiency will be less. Now we will move to types of batteries: lead acid battery, nickel metal hydride battery. If you talk about lead acid battery, it's a very old battery. It was invented in the year 1859 by French physicist Gaston Plante. So it's a type of rechargeable battery ever created. This is the first battery which is rechargeable created. So compared to modern rechargeable batteries, lead acid batteries have relatively low energy density. So their ability to supply high surge current means that the cells have a relatively large power to weight ratio. So along with their low cost, make them attractive for use in motor vehicles to provide the high current requirement by starter motors. So nickel metal hydride battery, so NIMH or NIMH is a type of rechargeable battery. The chemical reaction at the positive electrode is similar to that of the nickel cadmium cell, with both using nickel oxide hydride NiOH. The negative electrodes use a hydrogen absorbing alloy instead of cadmium. So these batteries can have 2 to 3 times the capacity of NiCd battery of the same size with significantly higher energy density, although much less than lithium ion batteries. So lithium ion battery is the very popular battery which is used in most of the gadgets as well as electric vehicles. So it is also a kind of rechargeable battery composed of cells in which lithium ions move from negative electrode to through an electrolyte to positive electrode during discharge and back when charging. So Li-ion cells use an intercalated lithium compound as the material at the positive electrode and typically graphite at the negative electrode. So Li-ion batteries have a high energy density, no memory effect other than LFP cells, and low self-discharge. Cells can be manufactured to either prioritize energy or power density. So flexible to manufacture. Then sodium based battery, then metal air battery. These are very less popular and it has its own advantages and disadvantages. Then we will move to battery modeling. So battery modeling is an excellent way to predict and optimize some batteries. Basic parameters like state of charge, battery lifetime, and charge discharge characteristics. Over the years, many different types of battery models have been developed for different application areas. This battery modeling requires to address the particular application. So whether it requires high voltage or it requires high amps or it requires more power, like that we can model it by connecting seriously or parallelly, we can do it. So equivalent circuit models, battery equivalent circuit models, ECMs, are widely employed in online battery management applications. The model parameters are known to vary according to the operation conditions such as the battery state of charge, SOC. So battery model, it has very different models. RIND model is also a popular model. Thevenin electric model is also a popular model. Second order RC Thevenin model. Then accurate electrical equivalent model is also a popular model. Whenever we need to charge a battery, the time consumption is an important factor. In order to shorten the charging time, we are preferring quick charging devices. So quick charging devices has main 3 classifications. One is rapid, fast, and slow. So measurement of power is in kilowatts. So actually quick charging devices power outputs and therefore charging speeds possible to charge any. So it obviously refers the time. So first classification is rapid charger, that is rapid DC chargers. In India it uses 50 kilowatt, approximately 125 amps. So connectors typically charge EV to 80% in 20 minutes to an hour. 20 minutes to 1 hour it will charge 80% of the battery. So depending on the battery capacity and starting state of charge, whether it is in 10% or 20%, it depends upon the time will be reduced or increased based on the battery state of charge. Then ultra rapid DC is there that provide 100 kilowatt or more. So these are mostly either 100 kilowatt, 150 kilowatt or 350 kilowatt, that is ultra rapid. So this is also possible. Then next classification, fast chargers. These are types 2 AC chargers. Fast chargers are rated at either 7 kilowatt or 22 kilowatt. Charging times vary on unit speed and the vehicle, but 7 kilowatt charger will charge a compatible EV with 40 kilowatt hour battery in 4 to 6 hours. and 22 kilowatt in 1 to 2 hours. Fast chargers tend to be found at locations. So these are type 2 AC chargers. Actually, it can be likely to be parked in an 1 hour or 2 to charge the car in the or a vehicle in the charging stations. If you talk about slow chargers, these are the chargers usually employed in home. 3 kilowatt to 6 kilowatt, and the car will be charged between 8 to 12 hours in order to charge the car overnight. This can be implemented. So for concluding the energy sources which is available for electric as well as hybrid electric vehicles, the foundation of electric vehicle performance, efficiency, driving range and environmental sustainability purely depends on the energy sources. So what energy we are using, actually whether we are using solar energy or wind energy or tidal energy or fossil fuel obtained electric energy. So that defines the driving range, vehicle performance, whether it is supports environmental or not, like that. So lithium ion batteries remain the most widely used energy source due to their high energy density, long life and improving cost effectiveness. So emerging technologies like solid state batteries, hydrogen fuel cells and supercapacitor have the potential to overcome current limitations. Then renewable energy sources including solar, wind power play a vital role in making EV transportation more sustainable by reducing greenhouse gas emissions through the energy supply chain. So the daytime available energy can be coupled and it may be stored or it may be given to the grid, and whenever the vehicle required it can be used, or the vehicle to grid or grid to vehicle concept can be employed effectively. The development of fast charging infrastructure and smart energy management systems is essential for improving the practicality of widespread adoption of EVs. Then battery recycling, second life applications and sustainable material sourcing are increasingly important for minimizing environmental impacts and ensuring resource availability. So with this conclusion, I am thank everyone for your wonderful time. We will meet again. Thank you.